3.2, the graph of a function. So we're going to use the vertical line test to determine which of these three graphs, if they are or not functions. So you might use a piece of paper, you might use a ruler. I like to use a ruler. So as we go along this graph, as we go along that graph right there, do you notice how the ruler only touches the graph once at every single point? It does, right? So instead of using a ruler, some of you might do what's called the vertical line test, which, I mean, the ruler is the same thing. So see how the green meets the blue line only one time? Every time? See, only once here, once, one time. So this is a function. Let me redraw that. It's a quadratic. I just suck at drawing it. That's more like it. I mean, it's the same thing. It doesn't matter. That's just as equally bad. So I'm going to use my ruler. As we go along, remember quadratic goes up and out. So it goes out as it goes up. So it doesn't hit more than twice. If we wanted to use the vertical line test, we could do that. You can see how it only hits one time, one time, one time, one time, one time. So this is a function. If I go along the circle, nope, it's not a function. It's not. Look at how many times the ruler hits the circle multiple times. And if we use the vertical line test, so you see here how it hits twice, two times, two times. This is not a function. Alright, obtain information from a graph. So we're given a graph and we're going to answer a bunch of questions, A through L. Yeah, we're going A all the way to L. So we want to find f of negative 35 and f of negative 15. So f of negative 35, this is where x goes, right? Isn't this f of x, f of x? So what we're given x equals negative 35 and x equals negative 15. So let's go to there. Negative 35 is right here. Negative 15 right here. So let's look at the y next to it. The y next to it is negative 10. The y next to negative 15 is positive 15. So our answer is f of negative 35 equals negative 10, and f of negative 15 equals 15. Because remember that this is x, this is y. This is x, this is y. Yep, that's all we're doing for that. Why is it important to know how to look at a graph? Because looking at a graph can give us way more answers than actually listing those points. So it's easier for us to see something graphically and using a picture than it is to have this giant list of thousands and thousands and thousands and an infinite amount of points, by the way. There's an infinite amount of points on this blue graph. So I want you to pause and try to do B. It's just the same as A, so go ahead, do that. Alright, let's do this together. So we have f of 30 and f of 0. So f of 30, that means x is 30. So let's find that. X is 30 is right here. Y is 10. And remember, it's x and y. So when f is 0, when x is 0, when we have x at 0, that's right here. We have negative 5. And again, that's x, that's y. Alright, without even explaining this to you, I'm just going to ask you and go back to the graph and let's figure it out. Is f of 10 positive or negative? Just a reminder, that's x, so we're saying x is 10. So let's go to where x is 10. There. What do you think the answer is? It's negative. Why? Because the y is negative. So the answer is just negative, but I'll tell you why. You don't ever have to tell me why. I just like to do it for your notes. This way you understand why. And the reason why is because when x is 10, y is negative 10. So therefore, it's negative. Those 3 dots mean therefore. Alrighty, let's keep it going. Part D is same thing. Go ahead, I want you to pause and try part D. Alright, so we have f of negative 35. So let's go to where f is negative 35 right here, and negative 10 is attached to it. So f of negative 35 is negative. Same reason. So for what value or values of x is f of x equals 0? As a reminder, f of x, that just means y equals 0. So we're given y, now we're looking for x. So let's go to where every y is 0. So here, y is 0. Y is 0 here. Let's see, any more? Y is 0 here. So those x's that are attached to it are negative 30, negative 5, and 20. Now we just write it back in our function notation. So we have f of negative 30 equals 0, f of negative 5 equals 0, and f of 20 equals 0. When y equals 0, what are we finding? We're finding x-intercepts. That's actually what we just found, are the x-intercepts. So just keep that in mind. All right, part F. Part F, I will be, it's going to be the trick question of this. So bear with me, slow it down, maybe replay it a couple times. It'll be okay, we'll get this. So for what value or values of x is f of x greater than 0? So that's a completely different question because of the sign. The sign is completely different. So let's not even pay attention to e. So what we're talking about is y is greater than 0. So if we look at the graph, y is greater than 0, that's on the top part of the graph. So we're only going to be looking at the graph that's above and on the top part. So that means this part, that's above y equals 0, right? Because that's positive y's. And this part. Those are the only parts on my graph where y is greater than 0. So when it's asking about that, it's asking for what values of x. And since we have the inequality sign, we're talking about intervals and interval notation. Because we have x and an inequality sign, we're talking about intervals. So meaning from what x to what x can I plug in to get y be bigger than 0? So reread left to right, it starts at negative 30. And we keep going until it stops. So here it's still going, it hasn't stopped yet, it hasn't stopped. Here it has stopped. It stopped at negative 5. Now, bracket or parentheses. Since there is no line underneath, let's go back to those two numbers, negative 30 and negative 5. So the y that is with it is 0. 0 is not greater than 0. Since that is not true, that's a parentheses. We do the same thing for negative 5. So at negative 5, 0, that's the point that it stops. And 0 is not greater than 0. So since that's not true, it's a parentheses. Remember, intervals, that means every number between negative 30 and negative 5. Every number between those two is included in that parentheses. So let's keep going. Go back to the next part. If there's a break, since there is a break, it's a union, meaning we have to stop, right? Didn't we stop here? We're going to start again here. So we start again at 20. So we're at 20, and the graph stops at 30. So I can't keep going. So at 20, we're going to look next to it. At 20, it's with a 0. 0 is not greater than 0. so parenthesis. At 30, it's 10, so 10 is greater than 0. Since that is the case, it's true, bracket. Watch that again. If it's not making sense, watch it a couple times. Alright, now let's find the domain. So the domain, what values are those again? Are those x or y? So domain, remember, those are your x values. So we're going to go to our graph and determine our smallest and biggest x. Our smallest x is negative 35. Our biggest x is 30. So our domain is negative 35 to 30. Why are they brackets here for domain? Because they're closed circles. Closed circles mean brackets. Part H is asking us to find the range, and the range, those are our y values. So for our y values, same pretty much scenario, we go smallest y to biggest y. So smallest y is negative 10, biggest y is 15. And bracket because they're closed circles, so negative 10 to positive 15. Part I, what are the x-intercepts? We already did that, remember? That's why I kind of like said, hey, those are x-intercepts. We already did that in part E. But since it's saying what are, we need to list them. And to list them, we say x equals, and then we list our values, negative 30, negative 5, 20. If it wanted a coordinate point, it would say coordinate point. It would say that. It would say how it wants your answer. It would say coordinate point. It would say list, which also means R. So coordinate point, that would be negative 30, 0, negative 5, 0, and 20, 0. Let's see, what are the y-intercepts? Since it says R, we're going to list them. So we have y equals. So for the y-intercept, we want x equals 0. So x equals 0 is right here. Oh, my bad, wrong one. Is right here. And when x is 0, y is negative 5. Alrighty, part K. How often does the line y equals 1 intersect the graph? So y equals 1, that line. Let's go to where y is 1. Y is 1 is about right here. It's about there. So we draw a line that goes through that point. And how many times does it cross? 1 time, 2 times, 3 times. That is the answer, just 3 times. For what value or values of x does f of x equals 15? So we're given y equals 15. What's x? Let's figure it out. So let's go to our graph. At y equals 15, x equals negative 15. So we'll have f of negative 15 equals 15. Example 3. Determine whether the graph is that of a function by using the vertical line test. So here's the graph. Let's use the vertical line test. I like to use rulers. So if we use a ruler to go along, yep, it's only hitting the blue once. If I keep going, yep, this is a function, totally. So, yes, this is a function. So part A, what is the domain in range? So my x's for my domain, do you notice that I have double arrows pointing down? If you have double arrows pointing down or up, your domain is always all real numbers. You might want to write that down. If you have double arrow up or double arrow down, your domain is all real numbers. The range is our y values. So I do have a start and I have a stop. So technically this doesn't this kind of look like a frowny face? It's because it is. Like it's a frown. It looks like a frowny face. So when you're frowning, your negative infinity, and our biggest y is 6. So negative infinity to 6, that is our range. If it was a smiley face, you would just flip them because you're positive when you're smiling. So our range would be negative infinity to 6. Alrighty, part B, intercepts. We do have intercepts. We have wherever the graph crosses the axis. We have 3 of them. 1, 2, 3. Now, they don't really give us the points here, so let's try and fill this out ourselves. There are 12 tick marks. What do I mean by tick marks? I mean, not 12 tick marks, 4 tick marks. 1, 2, that's a tick mark, 3, 4. So 12 divided by 4 is 3. That means this is 3, 6, 9, 12. So 3, 6, 9, 12, negative 3, negative 6, negative 9, negative 12. Oop, that's already there. And negative 3, negative 6, negative 9, negative 12. So we have 2 x-intercepts at negative 9 and 9. And then we have a y-intercept at negative 6, or positive 6. Symmetry. Do we have any symmetry? Let's see. If we folded this over the y-axis, it would go on top of each other because it looks like a frowny face. If it looks like a frowny face or a smiley face, it's always y-axis symmetry. So this is symmetric with respect to the y-axis. Example 4. We have a function, and we're going to figure out is the point negative 1, 2 on the graph of f. So if we're trying to figure that out, we plug in x and y. So we have f of x, which just means y, so 2 equals blank plus 2 over blank minus 6, and the blank we're plugging in is negative 1. We're going to simplify. We have 2 equals 1 over negative 7. That is not true. Since it is not true, negative 1, 2 is not on the graph. So no, that is not on the graph. If x equals 4, what is f of x? What point is on the graph of f? So it's just asking us to plug in x. Let's figure it out. So we have y equals x plus 2 over x minus 6. And in that blank, I'm putting in 4 for x. We simplify. So we have 6 over negative 2, which is negative 3. That means f of, we plugged in 4, equals negative 3. Remember, that's x, that's y. It also asked for what point is on the graph, and the point is 4, negative 3. Part C, if f of x equals 2, what is x? What point or points are on the graph of f? So now we're given y, let's find x. So we need to find x. So part C, we're given y for part C. So we have 2 equals x plus 2 over x minus 6. We're trying to solve for x, and anytime you need to solve for x and it's part of a fraction, you always multiply by the denominator. So when we do, we have 2x minus 12 equals, these cancel, x plus 2, we're going to solve for x, and when we do, we subtract x to both sides. So we're left with x minus 12 equals 2, add 12 over, so we get x equals 14. So that means f of 14 equals 2, and that point on the graph is 14, 2. Alright, let's find the domain of f. Let's find this domain. So I'm going to just rewrite our function for part D. So for part D, we're trying to find the domain, and remember, domain are x values, so we have to figure out, is this a fraction, a radical, is it all real numbers? So this is a fraction with a variable in the denominator, so how we find domain is we set the denominator can't be 0. So we have x cannot be 6. So we could say x such that x cannot be 6, or negative infinity 6, union 6 to infinity. Alrighty, part E, it wants us to find x-intercepts. So for x-intercept, remember we make y equals 0, so we have 0 equals x plus 2 over x minus 6. We're going to multiply by the denominator, same reason. We have 0 times x minus 6, which is 0 equals x plus 2. So we have negative 2 equals x. And that means we have, that's our intercept, and it says to list. So since it's listing, we just list it as x equals negative 2. Do you notice the only thing that was left was the numerator? That's a trick. If you want to find the x-intercept of a fraction, numerator equal to 0. Only a fraction, numerator equal to 0. Part F wants us to find the y-intercept. No trick, just make x equals 0. So we have y equals 0 plus 2 over 0 minus 6. So that's 2 over negative 6, which is negative 1/3, because we simplify. So we have, it says to list them, and we did. That's listing them.